Hello everyone, welcome to the Rainbow Dash template tutorial. Here you will learn about the Rainbow Dash templates. This video will introduce how to implement the effect of the spinning wheel mechanism by coding. Alright, let's get started. In the template, the specific effect of the spinning wheel mechanism is composed of two freezer throwers constantly rotating. So, what does it take to achieve such an effect? To achieve this effect, let's first build a spinning wheel mechanism model. Go to the editor and place two cylinder parts and one cube part in the scene. Adjust their size, position, and color. Note that the X coordinates and Z coordinates of the three parts should be the same. We make the red part be the center of rotation, let it rotate, and then move the blue part above it. To make the red part rotate, we can use the hinge in the part constraint. In the top menu bar, click on the drop-down menu button next to Weld and select Hinge. Move the mouse over the red part, and you can see a constraint anchor point. We click the mouse on the red part, and then on the yellow part. This way, we have created the hinge constraint. Select the constraint in the Game Resources view and set all parameters of relative coordinates of main anchor point, and relative coordinates of connection anchors to 0. This is to ensure that there is no rotation offset when the red part rotates the blue part. The weld constraint is needed to ensure that the blue part can be rotated. Click on the weld constraint. First click on the red part, then on the blue part. In this way, we have roughly completed the construction of the spinning wheel mechanism. Before we start writing the code, we need to change the names of the three parts. This is because in the code we have to get the corresponding part in the scene according to the name of the part, so it is better not to repeat the part names. After modifying the name, let's create the script for the spinning wheel mechanism so that it can rotate. Click Game Settings, select Triggers and Scripts, click Server Script Management. In the Server Script Manager, click the New Lua Script button in the upper right corner to create a new script file. Right-click on the script, select Rename and type Turntable. Double-click the script to open the script editor. Next, we'll use the script to handle the logic associated with the spinning wheel mechanism. Let's start by defining three variables. They are: turntable for the current module. The pivot represents the red part. The pointer represents the blue part. Then, we define an externally accessible function, with which to start the spinning wheel logic. Within the function, the first thing to do is to first get the red part and blue part in the scene. To implement this logic, you need to get the root property of the current scene map first. We can send a map parameter to this function to get the root property. This allows us to get the part with the specified name by calling the findFirstChild function. The findFirstChild function requires two parameters, the name of the part and a Boolean value. When the Boolean value is true, it means that the editor will search for the specified child node recursively. Otherwise, it will not. More API-related content can be found in the official API documentation. After getting the specified parts, we have to enable one timer. The logic for defining and enabling the timer is written like this. The new function has two parameters. The first parameter is the number of frames, at which the specified callback function will be executed once. Here it is written 1, which means that the callback function will be executed once every 1 frame. The second parameter is the specified callback function. The loop property refers to whether the current timer is looping. The start function is the interface to start the timer. After setting the timer, we have to write the logic to make the spinning wheel rotate in the callback function. Since we are using the hinge constraint, we only need to assign a value of type vector 3 to the angular velocity property of the part. However, in order for the blue part to rotate properly, we only need to set the angular velocity on the y-axis, leaving the x-axis and z-axis at 0. Go back to the editor and open the server script management interface. Double-click on the main script, which will be executed by the editor when the game starts. We load the turntable module in the main script. Use required to load the module. Note that the path to the module should be complete. Then we can start the function in the turntable module. Before calling the function, we also need to use the world class provided by the editor to get the specified map. The getStaticMap function of the world class can get the specified map, but the function requires the ID of the map to be transferred in. The map ID can be obtained by selecting the corresponding map in the Game Resources view, then right-clicking on it, and selecting Copy ID. To prevent the part from not fully loaded when the script is executing, we can use a timer to delay the call to the start function in the turntable module for a while. After completing the code, let's go back to the editor and click Run to see the result. You can see that the blue part are successfully rotating. In the template, when the player touches the spinning wheel mechanism, they will return to the last checkpoint. To achieve this effect, we need to implement the collision detection logic between the player and the spinning wheel mechanism. In the editor, there are two ways of registering a trigger. The first one is to use the register handler function under the trigger class. The second one is to use the addhandler function under the trigger class. The difference between the two is that the register handler function overwrites the existing trigger with the same trigger name, while the addhandler function saves all triggers with the same trigger name, and then triggers them in turn when triggered. Because the game registers many triggers that detect collisions with parts, so we choose the second way. The addhandler function requires 3 parameters. The first parameter is the configuration information of the activating trigger object. Here we get the player's configuration information through the entity.getConfig function. The second parameter is the trigger name. Here we are using the trigger of the entity colliding with the part. The third parameter is the callback function to be executed after the trigger is triggered. Note that the trigger names are built into the editor. More trigger names can be found in the official API documentation. According to the API documentation, there is one parameter in the trigger callback function. The object1 field of this parameter indicates the object that triggered the trigger, which in this case is the player. The part field of this parameter indicates the part that collided with the player. Because there will be many parts in the game scene, so we have to determine whether the parts colliding with the player and the spinning wheel parts are the same. If it's the same one, we then handle the subsequent logic, such as returning the player to the last checkpoint, or killing the player. The specific logic can be adapted to the content of your own game. As for the content related to checkpoints, will be explained in the subsequent tutorials video. Here, we'll start by writing a log to see if the collision trigger is in effect. Finally, let's organize the code again, and put the collision trigger logic into a separate local function. and then just call that function in the startup function. After completing the code, go back to the editor and click Run to see the results. In the console, you can see that the log appears, indicating that the collision trigger is in effect. The spinning wheel in the template is composed of 2 freezer throwers. Next, let's revamp the spinning wheel mechanism we just built. First, select the blue part and adjust its transparency to 0. Then add 2 effects to the part. The effect type, select freezer thrower. Then adjust the position and towards. Does this look more like the spinning wheel in the template? As for the bottom model of the spinning wheel mechanism, you can mix and match for your preference. That covers all the content of this video. I hope this content can help you make better games. To learn more about the content related to the Rainbow Dash template, you can leave a comment below the video, or post it on the official forum. See you in the next video.